Okay, let's move on to another basic equation. This one's actually got a decimal in it. So the process is the same. It's just a little bit more complicated once you start having fractions and decimals. So let me write it off to the side again. And we want to isolate our variable. That's our goal. We want to solve for n. So goal is to get n equals something. And right now, n is multiplied by 0.5. So even though it's a decimal, you want to follow the exact same process. How do you cancel out multiplication? You want to do the opposite. You want to do the opposite operation of division. So we will divide by whatever we're multiplying by. Divide by 0.5. And something divided by itself, 0.5 divided by 0.5 is still 1. Okay, as long as they're the same in the top and the bottom, this will always be 1. So these cancel, and you get that n is 4.5 divided by 0.5. Now, you can use a calculator for this, or you can do the long division by hand. Let's do that. So 0.5 goes into 4.5. Remember, when you're dealing with decimals, you want to get the number on the outside to be a whole number. So we're going to move this decimal place over 1, which means we got to move this decimal place over 1. So really, this just becomes 5 goes into 45 how many times? And that answer would be 9. So in this case, n would be 9. And at this point, we can check our answer. So let me change colors here. So we're checking, we're plugging in n equals 9 into the equation. So we got 4.5 equals 0.5 times 9. And remember, when multiplying decimals, 9 times 0.5, we multiply ignoring the decimals, so you get 45. And at the end, we count up the decimal places in each of our factors. There's none here, and there's 1 here. And we just move it over the total between the two, which was just 1 in this case. So you do get 4.5, which means that we can feel very confident that n does in fact equal 9. Okay, let's move on to some more problems. So this one again has a decimal here. So we get that 5 is equal to w divided by 2.2. So we know our goal is to get w equals something. And right now, w is divided by 2.2. It's divided by this decimal. But remember, it's the same process as if this was a whole number. We want to cancel out this division with multiplication. We'll multiply each side by 2.2. And 2.2 divided by 2.2 is just 1. So this side will just become w. These cancel each other out. Since we know anything divided by itself, doesn't matter if it's a decimal, a fraction, a whole number, these always cancel out and we always get 1. And over here we have 2.2 times 5. I apologize, that's a little bit messy. So let's do that over here, 2.2 times 5. First, you want to ignore the decimals when multiplying decimals. So 22 times 5 would be 110. And at this point, we just need to put the decimal place in. There are 0 decimal places in this factor, and there's 1 in this one. So we have 1 total, so I'll move it over 1. And so you get 11.0, or just 11 for your answer. And let's double check this. Make sure we did this right. We know that if we take w and we divide it by 2.2, we should get back to 5. So we will check off to the side. You want to do this on every problem. So is it true that 11 over 2.2 equals 5? Is that true? So we have to do our long division here. So 2.2 goes into 11, but we got to move this decimal once, which means we got to make a decimal place here. So this just becomes 110. So we're figuring out how many times does 22 go into 110, and we know this goes in 5 times. So we got back the answer we expected, which means we can feel confident that w does in fact equal 11. Okay, moving on to this problem. So we have 1/2 a equals 11. And with this problem, we have 1/2 times a. So there are a couple different ways to interpret a problem like this, but let me rewrite it. So 1/2 a equals 11. So we do have multiplication. So you could use division to cancel that out. All right, we know we want to get a by itself. A equals something is always our goal, whatever our variable is. In this case, it's a. And to cancel out multiplication, let's just use division. So it's a little bit complicated because we have to divide by a fraction. But I'm going to divide both sides by 1/2 to cancel out that multiplication. And this might look complicated, but it is true that 1/2 divided by 1/2, right? We're just taking something and dividing it by itself. You have the 1/2 up here and the 1 down here. Something divided by itself is always 1. So these are going to cancel, and you're just going to get a. So that and that both go away. Let me use a different color just to make it clear. Now, a would be equal to 11 divided by 1/2. And let me write that out explicitly. 11 divided by 1/2, since it might be easier to interpret it when I write it like this. Since we know if we divide by a fraction that it's the same as multiplying by this fraction flipped over. So this is really 11 times 2/1, and multiplying fractions, you just go straight across. If you have a whole number, just put it over 1 to make it a fraction. And 11 times 2 is 22. 1 times 1 is 1. I'm not going to write that, so a is just equal to 22. And we can check it. Let's check our work here. And we want to put back in 22. So 1/2 times 22, does that equal 11? And it does, since if we put this over 1, 1 times 22 is 22, divided by 2. Since we have 2 times 1 on the bottom, 22 divided by 2 is 11. So we can feel confident that this is the right answer. Now, like I said, there are other ways to interpret this. And one of the other ways to do this, since this is kind of messy with the division of fractions and all that, so what you can also do is rewrite 1/2 a equals 11 as just putting a inside this fraction. So you could think of it as a over 1 and then just multiply across. Since these are now two fractions, you get 1 times a, which is a, 2 times 1, which is 2, equals 11. And now you don't really have to deal with dividing by fraction. Now you're just dividing by 2, and you can use multiplication by 2 to cancel that out, and you get that a is 22. So that is another way to think about it, but it's effectively the same thing. You still get the same answer. So let's move on to our last problem here. Again, we're going to be dealing with fractions. This one's a little bit more difficult. So we have this kind of proportion set up. 2/3 is equal to what over 15? And there are several different ways to interpret a problem like this. Let's just go through the basic one, though. So 2/3 equals z over 15. Our goal, as always, is to get the variable by itself, in this case z, equal to something. So right now z is divided by 15, and so we need to cancel out that division. We will do that with multiplication. Multiply both sides by 15. I'm going to put this over 1 so we can multiply fractions here. And 15 divided by 15, these cancel, and you just get z on the right side. And on the left, you get 15 times 2 up top, which is 30, and 1 times 3, which is 3, down below. And so 30 divided by 3 is just 10. So z would be 10 in this case, and we can check it. Let's switch colors for that. So we're going to put in z equals 10, so we get that 2/3 equals 10 over 15. We're just wondering, is this true? And 10 over 15, we can simplify that fraction, since if we divide top and bottom by 5, then what we get, 10 divided by 5 is 2, and 15 divided by 5 is 3. You get back to 2/3, which means that this is true, which means that z does, in fact, equal 10. Now, another way to interpret a problem like this is, since these two sides of the equation are equal, you're basically saying, if I unsimplified this fraction, what would this new numerator become? So this is essentially what you always do when you add and subtract fractions. You make fractions effectively unsimplified. So you want to think, what did you multiply the 3 by to get to 15? You multiply by 5. So you got to do the same thing to the 2, or else you change the equation. So 2 times 5 is 10. So that's another way to think about where you get that z is equal to 10.